Okay, so this is our last section in the matrices chapter here. So it's going to be translations. Do you guys remember what translations are? It's sliding something, yeah. So if we have a translation, basically you've got a picture or a line or whatever, and we're taking it and we're sliding it so far. So we did that some in geometry where we do some slide stuff. Now we're just going to be sliding stuff on the graphs. We got that definition there. So in that definition, the transformation that maps xy onto x plus h and y plus k is a translation of h units horizontally and then k units vertically, and is denoted by the t there for translation, and then h or sub h and k. So basically you're just taking your x coordinate, whatever it is. If you're moving like to the right 5 units, you would just do like whatever your x coordinate is plus 5. If you're moving to the left, it would be minus, because it'd be like negative, right? Because you're going the opposite direction. And then same with like your up and down. If you had to slide something like up so many units, you would take your y values plus whatever that value is. If you have to slide it down, you would just take your y value minus whatever that is. Okay, so using the matrices to do this, kind of set up similar to when we have like ordered pairs for this. So like our top row is going to be all h's, and our bottom row is going to be all the k's. So whatever your h number is, you would just write that for every number on the top. Whatever your k number is, you do that for every single one on the bottom. And then you just do it as many times as you need to. So like if there was like 5 points you were doing this to, you would do 5 of each of those. If there was only 2 points, you would just do like 2 and 2. And then that parallel lines and translations theorem. So under a translation, the pre-image line is parallel to the image. So when we do this sliding around and stuff, whatever your original line is and your new line, they're always going to be parallel to each other. So if it says something about parallel lines, if you do a translation, you get parallel lines. Okay, so let's take a look at that first. Yes, you can use your computer. Okay, so let's take a look at that first one there. So quadrilateral has vertices M, A, T, and H. Find the image of math then under the translation T sub 6 and then -9. Okay, so what we're going to do is we actually add with this stuff. So instead of multiply like we've been doing, so here it's adding your H values and adding your K values. So you're just going to take, and it doesn't matter the order here on our addition stuff, I'm going to take my original matrix, MATH. So that would be 1, 3, 5, 6, 8, 10, and 3, 7. And you're going to add that to the matrix that has all of our H movement on the top and our K movement on the bottom. So our H movement is our horizontal movement, so that's going to be the 6. So up top here, we're just going to go 6, 6, 6, and 6. So we do 4 of them because there's 4 points we're doing it to. The bottom, each of those we're moving by -9, so that would mean like down 9. So you'll have 4 -9s across the bottom there. And then with adding, hopefully you guys remember when we add, you just have the, your matrices have the same exact dimensions, and then you just take the individual points that match up, so like the 1 and the 6, add those together, and then that would go right there. So like 1 plus 6 would be 7. I'm just going to go across the top there. 5 plus 6 would be 11. 8 plus 6 would be 14. And then 3 plus 6 would be 9. So that would be all of our new x coordinates, and these would be like m prime, a prime, t prime, and h prime. And then you just do the same thing with your bottom row there. So again, like they're just going to match up with their same position when we add. So you just take the 3 plus -9, which would be -6. 6 plus -9 would be -3. 10 plus -9 would be 1. And then 7 plus -9 would be -2. And then that would just be your new shape. So then I would just take both of those, and they want you to graph your original one and your pre-image. So your original one would be the MATH, so 1, 3, M, A is at 5, 6, T is at 8, 10, H is at 3.7. Kind of a skinny little guy there. So we connect those to make our polygon there. And then just for the heck of it, I'm going to do my other one in a different color just so we can see that it's different. So M prime would be at 7, -6. Ooh, it looks like I'm going to go off my graph here a little bit, aren't I? Might have to extend this graph out a little bit. What do we got to go out to? 14. So that's 10, 11, 12, 13, 14. Not ideal, but we'll go with it. So 11, -3, 14, 1, and then 9, -2. And then sketch that guy in. Might look a little off because we had to draw those extra lines in there, but close enough. And it should look like our shape there was slid 6 spaces to the right because our x value was +6 or +6. Our y value is -9, so it should look like it went to the right 6 and down 9. Does that seem fairly accurate? Yeah, so it should always look like the same shape when we do our translation because it's just sliding it around. Okay, and then the next one here. So find the image of the line with the equation y is equal to -2x + 7 under a translation of -4, 5. Okay, so when we have equations and we do translations on it, we had a theorem before that told us that they were always going to be parallel lines, right? So if our original equation and our new equation have to be parallel lines, what do we have to have that stays the same? What do parallel lines have the same? Slope, right? So currently our slope is that -2, so we want slope stays -2. Okay, so we're going to need that. Then what's a little bit tricky here is we've got to do a translation of like a specific point, but do they give us a specific point here? No, but could we come up with a point that is on this line that we could use? Probably. If it was in the form like y minus y is equal to m and then x minus x, we could pull a point straight out of that because that's in point slope. Here this is in slope intercept, but what do we call this back number here? The y what? Intercept. And if that's the y-intercept on like a graph, wouldn't that be like a point there at like 7? What would be the ordered pair at that point? 0, 7, right? Because aren't we going over 0 and up 7? So wouldn't 0, 7 be a point on that graph? Yeah, so we could take that point, do our translation movement to it, get a new point, and then use that as our equation, right? So our original point here, so let's just write point on original, or like the pre-image, is 0, 7, just so you know where that's coming from. And then we're going to do that translation to this point 0, 7. So if we go translation of -4, 5 on that ordered pair 0, 7, we're going to see what we get kicked out. So again, basically you're just taking in your subtracting 4 to your x coordinate, adding 5 to your y coordinate, so 0 minus 4, -4, and then 7 plus 5, 12. So that would be a new point under that translation. So couldn't we use our parallel slope and a new point to come up with the equation? Sure could, right? So we've got a slope and we've got a point, so we could go into point slope form. So y minus our y coordinate would be 12. It's equal to slope is -2. Yep, and then x minus, and our x coordinate would be the -4. And if we want to, we could switch that to plus positive, and that would work. If you did want to solve it out all the way to like y equals to get like that one, you could too, but again, it just says find the image of it or whatever, so you could just go with that. Go with that, and that would be fine. Okay? All right, that's it. So you got that book page for tomorrow, and tomorrow will be worksheet day. We'll have a quiz over this stuff on Monday.